And so this week we're going to talk about setup reduction. Also, it's been sometimes called SMED, which basically means single minute exchange of dies. It was originally developed for changing out dies out in the manufacturing area. These are big dies that are used on presses. We'll talk about a little bit more. The purpose of today is to kind of give you an overall idea of the concept and how it works and some of the tools that are available. So we're going to talk about why SMED. We're going to give you an overview of the process. And then today we're going to just go over the tools and examples. We're not going to do the practice. We do actually have a 2-hour class where we actually pick a project and we do a project as part of the example. We won't be doing that today. We'll be basically doing the first 3 steps. So as I mentioned, this is the guy, Shigeo Shingo, is the person who invented SMED. And what it doesn't mean that you can get a exchange of dies done in less than a minute. It means it's in the single minutes, which means it's 1 to 9 minutes versus 10 to 12. So you get into double digits, that's beyond single minutes. And basically, it's a theory and technique for performing setup operations in under 10 minutes. And when they talk about setup, they mean from the time between the last good piece off the current run to the first good piece off the next run, which should be first good piece. But it has to do with time from the last good piece to the first good piece to the next run. And, you know, if you've ever seen like a pit crew, I mean, it's the whole idea of everyone has a job to do, and when that machine goes down, basically you're doing everything right or again running again. It was revolutionized by Shigeo Shingo in the 1950s in Japan, and it is a key part of lean manufacturing principles. And my question to all of you is, why do you think it is a key part of the principles? Anybody? So it reduces the weight. Well,
you get more
if you have, go ahead, Mark.
I say it's productivity increase. So if you had 60 minutes and you take 20 minutes to change a die, your throughput on a piece of equipment is less. So you get it down to shorter time, you get more capacity.
Right. That's good. And there's another big one. So if I have really long changeover times, what does it mean in terms of how I'm going to schedule my products?
You got to build more inventory.
Yeah, I'm gonna basically batch up. Because it takes so long to change over, I'm gonna make a big batch of products before I change over again, right? Because I know that every time I change over, I'm losing production. So what I'll tend to do is I'll tend to make things to inventory. Like this morning, we were at a client, and they said, well, we run this product. We run 5 weeks worth of product because we don't want to have to change it over more than once every 5 weeks for this one product. So they're holding all in inventory. So imagine that the changeover time was a minute. Well, if the changeover time was a minute, you could make what you needed every day instead of making it to inventory that you may or may not need. So that's one of the big principles of this, how you increase your flow because you're making smaller batches of products, with the idea being you just make what you need when you need it. So here's some of the things that we talked about. Equipment capacity is increased. The cost of setup labor is reduced. The big one, order size can be reduced. Setup scrap is reduced. Potential quality problems are reduced because we have a specific way of setting up equipment. If you do setup differently each time, we saw that at one of our other clients last year. If they don't set things up right, then you end up with quality problems later on. You start getting scrap because they're not precise in how they set it up. And scheduling accuracy is improved. We have a better idea how long it takes to do changeovers. Our accuracy for scheduling is better. Sometimes when we go out to places, we say, how long does it change over? Like from a half hour to 2 hours, depending upon how it goes. It's really hard to schedule when you really don't know how long it's going to take to do a changeover. Here's the overall process. So basically there's 7 steps. There's study the existing process. We're going to go through each one of these. Classify the operations. Eliminate waste. Convert internal to external. Improve the internal operations. Improve the external operations. And finally, standardize. Let's go through each one of these. Study the existing process. So this is where you go out with a videotape, or you observe, and maybe you have a stopwatch, and you identify all the elements required to complete a changeover. So you might be looking, so you're going to write down the element name, the sequence, what event, what sequence they do each task, what methods are used, what tools do they use, do they have fixtures, do they have screwdrivers, power tools, what the layout is, and what the cycle time is. So since we're going out there, we're watching multiple cycles of a changeover. Once we do that, we take each one of those tasks and we classify it. And it's going to fit into one of three categories. Either it's waste, which is any activity that does not add value to the changeover. So it might be, they're having to walk way out of their way to go get something that doesn't, a lot of extra walking is waste. Or something special they do to, for luck, It has nothing to do with what they really need to do to make the changeover complete. Internal setups are operations that can only perform while shutting down the machine. So, like getting in and changing a die, obviously the machine has to be shut down before you can do that. Those are internal things that are done while the machine is down. Finally, external things that can be performed without shutting down the machine. So what's an example of an external element? Right, so maybe bringing the new die into position so it's all ready to go. Or maybe preheating. Sometimes people preheat dies if they have to be heated up for use or chilled. They'll pre-chill them or preheat them. Yeah, getting all the tools ready to go, all exact tools that you need. Other things that have been done before the machine is shut down. We worked with one client where they would have materials that weren't spec, and they wouldn't know until they're halfway through the setup, and they'd realize that something they had was the wrong material, or maybe it wasn't to the correct specifications. So they'd have to take everything back down again, and then now they make the materials for the next run. So one of the things that we said is go ahead and you need to make sure all the materials are good, they're in spec, have the right amount of materials, the right materials. This can also be after you do the changeover, things that you could do afterwards, like putting things away. Previous die, you don't need to put away the previous die while the machine is down. You can wait till the machine is running again. So those are all things that are external. So waste, and again, any non-value-add time that's spent during the changeover. So excessive walking to get parts, tools or information, time spent looking for misplaced parts, or paperwork that's not required by the customer. That would be waste. So what you want to do is get rid of all the waste before you do the rest of the process. So now if we look at time here, this is the beginning of a changeover to the end. Or changeover preparation activities that are now, we want to make those external. We have when the machine is stopped. Those are internal to the machine. And then we have changeover cleanup activities, which are get external. So the goal is to take anything that's currently done while the machine is down and move it before or after the machine is down. Same number of activities, we just don't want to do it while the machine is stopped. So once we do that, move everything out of that middle range. We have certain things that have to be done while the machine is down. So here's some things that you can do to reduce those times while the machine is down. One is parts removed from the attachment. There are ways to reduce the time to remove parts and attach dies and things, like use of quick release fasteners instead of nuts and bolts. Use of stop pins or marks to quickly position equipment. Using power tools whenever practical. Could be really simple. I've seen ones where they had a tape measure that was basically permanently affixed to the machine, and they use a tape measure to measure out exactly where the, instead of having to take out a tape measure each time and measure it out, and the tape measure basically attached, it has a basically extends this one guide to measure out where exactly that guide was. I've also seen cases where they'll have a little mark on a dial, and they have to just move to where that mark is, and that means they're lined up. So that would be parts removal and attachment. Organization. You can kit required materials and tools for completing the changeover. They do that to one of our clients, a big kit on carts for everything we need in order to set up the line for certain products. They're actually like shadow boards, so you can actually see where everything's supposed to go. We have specific locations for all materials and tools. So by improving organization, we don't have as much waste because we're not spending time looking for things, tools or materials, fixtures. And then finally, the last philosophy I'm going to mention is teamwork. So what you want to do is create and practice a pit crew plan for completing setup. Now everybody should have a specific thing they're going to do. I'll show you an example in a minute, but you ever see a pit crew, they know exactly what their job is, and they know when they're supposed to do it and what sequence. And it's all practiced so that every time they do it, it's going to be the same. And I did this with a client once where they had 25-minute changeovers. We got up down to 4 minutes. We got down to 4 minutes because everyone knew when that machine went down exactly what their job was. And they knew that if they were ahead of somebody else, what they were supposed to do about that. They'd actually go over and help the other person. They went from doing 3 or 4 changeovers a day, they almost do like 25 changeovers a day. Now, this particular client are making CDs for music, and they were starting to make CDs for video games. And if you can imagine CDs for video games, this was back in the early 2000s, they would make 1 million CDs for music at a very long run. So when they did games, they were very short. So they not only compete with short runs, but with the duration of changeover times they were doing before. So this is something that was necessary for them to build a transition plan. And then once you improve the internal operations, then finally you improve the external setup. So apply visual control principles like color coding and labeling, checklist. So if you're going to prepare for a changeover, you might have a checklist of everything you're going to need for that changeover. Organize the workplace to reduce search using 5S, and then I mentioned for preheat or presetting of equipment. There's ways you can set it up so that basically one side's out and one side's in. And some places will even go as far as to have conveyors, and essentially the conveyor shuttles the old die out with new die in, and within a minute they can change over the whole machine. And then the final operation, this would go for any kind of improvement would be standardized. Once the best practice changeover has been identified, you want to document the plan, create work instructions and visual aids, train everybody. You want to practice. So everybody can consistently complete the changeovers within the standard time. You also want to monitor the changeover time. So like we did a project for a chemical company, purposely not giving names, but chemical company that's local. We were helping with changeover reduction. We were tracking changeover on different shifts. We found that third shift was taking longer than the other shift. So then it told us we need to do something. There's a reason why it's taking longer. And so it gave us an action plan. They gave us using a different method. So by monitoring the changeover times, again, from last good part to first good part of the next operation, we were able to see people were really adopting what we had told them to adopt. And then, of course, improve changeover standards and better ideas improve. When you talk about Kaizens, this is the type of Kaizen that I see a lot. As changeovers, anyone who's going to more customization of products requires more and more changeovers to happen. They can't afford to do a long run with one big runner that they sell 1 million of. They have to start doing smaller batches, and that means changeovers becoming more and more important. And here's some of the different tools we have available. This is a collection form. So you can see if we were going out, we identify the operation, the person, the date, who it is that's observing, the step, what the activity is, and then you identify the cumulative time when you're watching. So if you're watching, you've started time 0, and you would be, as you go through, it tells you what the cumulative time is. And then from that, between the difference, the two lines, you can come up with the element time. And then what you do is identify, is this an internal, an external, or wait? Can I get rid of it? Does it have to be down while the machine is down? That would be internal, or can I move before or after? And then, of course, any comments or ideas or target, what the target time might be. We have a client that we did a proposal for recently, and this is exactly what we talked about doing for them, videotaping their operations and filling out a form like this. Staffing calculation. If you know the total amount of time it's going to take to do something from start to end, and you know what your target time is, so let's say you want to get a changeover done in 5 minutes, and it's 10 minutes worth of work. How many people do you need? So you take the total minutes of activity, which is 10 minutes, target changeover time is 5 minutes, so you divide it by that, that means it needs 2 people. So just a calculation, a real quick calculation to tell you what does your staff need to be based on the content of work and what your target is for doing the changeover. This is an example of a form that's been filled out. And you can see you start putting things in terms of preparation activities, changeover, internal activities, and then cleanup activities external. And we can basically start moving things around to see here how this works with the time. You calculate the time based on the difference. This one from 0 to 5 minutes and 20 seconds is 5.3 minutes, and so on and so forth. And then you can see where if you wanted to improve one of these, you could estimate a new time. So this says the target changeover time is 80 minutes. The planned changeover time is 71.5. You can also use man-machine charts. So if you have one person handling many machines, man-machine charts, another tool you can changeover reduction. I use this a lot. The changeover timing chart. So I put everything in 2-minute increments, and then I show different operators, different things. So I have internal operations. So this is a real example. We used to take 60 minutes to do the changeover. So what we did, we took a lot of things and we made it external. So this is before the machine went down. And then basically we had 2 people clearing the production line, and then 2 people load the feeder line, while the other person sets up the packaging machine. We complete the adjustment, we train the assembly machine, and we're done. So now we've taken this entire time here, 60 minutes, and now it's all done in a small amount of time, 18 minutes. Here's something else. This is an operator instruction sheet. It tells them exactly how to do a changeover. This is an example of a check sheet that says before you do a changeover, these are the things you have to do. Determine if order is ready for scheduling. Here's the list of all the things that need to be done. Order the changeover preparation, order changeover preparation. This is once you know that's ready for scheduling, and this is what has to be done. These are the actual changeover activities, these are proposed changeover activities. What we did in this case, and this is a CD manufacturer again, we figured out for each product what's a custom check sheet. So if you're writing a client label, there was a specific check sheet for that. Now this is from 2001. Here's an example of part of that where we said exactly where does the operator, the case loader, have to stand. So the operator actually stands right here. As soon as our machine is done, he opens it up, he takes things out, he puts it on the cart, comes over here, removes the overflow here. He walks over here, he finishes the setup on the sticker. He walks over here to finish goods, and then he's done. He does some of the finished goods too. I think he takes finished goods and he makes sure that everything is done on the end. The other guy is over here. Here, I believe, and he's basically loading in booklets and he's loading in trays. So he has steps that he has to do as well. And we actually trained to this. And again, we got it down like 3 or 4 minutes to change what was amazing. Anybody can do it too. wasn't like they had to kill themselves. They just knew where to stand and what they're going to do. There was a clear plan before they actually did the changeover. This is something a little more recent. We did this for cheese companies in town. So we said before slicer changeover, this is what they do. And we actually had binoculars representing planning. And then we had a rework person. And then once the machine's down, at their stopwatch, we kept doing this. I'm sorry, after it stopped, we started doing this as needed, and we had a certain amount of time to do it. And then after the line was running, we did this. We actually broke it up into a little bit more of an easy to read thing for them. So we also gave them an estimate of how much time it should take them to do. And that's it. So to sum it up, if I go back to the process again, study the existing process, we talked about the operations, it's either waste, internal, external. You eliminate the waste, you convert internal to external. So when the machine's down, you're only doing things you absolutely have to do when the machine's down. You then work to improve the internal and external operations, and then you standardize. All right, what questions do you have? Or am I just that good?
Well, you did a good job, Bill. One thing I noticed, though, and it's nothing to do with this presentation, but there are some